Imagine a world without electricity. No smartphones, no computers, no lights at night. Our modern world is built on a foundation of electrical engineering. This journey begins in ancient Greece and travels through centuries of discovery. We will meet the pioneers who dared to unravel the mysteries of electricity. Prepare to be amazed by the electrifying history of electrical engineering. Ha ha! Welcome to Franciumz Legacy YouTube channel. Our story begins in ancient Greece with a philosopher named Thales of Miletus. Around 600 BC, Thales observed a curious phenomenon. When he rubbed amber, a fossilized tree resin, with fur, it attracted small, lightweight objects like feathers. This was the first recorded observation of static electricity. Thales's discovery marked the beginning of humanity's fascination with this invisible force. His simple experiment with amber laid the groundwork for centuries of future investigation. Fast forward to the 16th century, and we encounter William Gilbert, an English physician and scientist. Gilbert was fascinated by magnetism and its relationship to the attractive force observed by Thales. He coined the term electricity from the Greek word for amber, electron. Gilbert meticulously documented his findings in De Magnete. He discovered that materials like glass and sulfur also exhibited this force when rubbed. Gilbert's work marked a significant leap forward. Benjamin Franklin, the American polymath, takes center stage in the 18th century. In 1752, Franklin conducted his famous kite experiment, demonstrating the connection between lightning and electricity. He flew a kite during a thunderstorm, and when lightning struck, the key became electrified. This dangerous experiment proved lightning was a form of electricity. It led to his invention of the lightning rod. Section 5. Galvani, Volta, and the dawn of batteries. In the late 18th century, Luigi Galvani discovered frog legs twitched when touched by two different metals. Alessandro Volta challenged Galvani's interpretation. Volta argued the electricity came from the contact between the metals. To prove his point, Volta created the voltaic pile in 1800. The voltaic pile was the first electric battery, a groundbreaking invention. Section 6. Ørsted's unification of forces. In 1820, Danish physicist Hans Christian Ørsted made a groundbreaking discovery that linked electricity and magnetism. During a lecture demonstration, Ørsted noticed that a compass needle deflected when an electric current flowed through a nearby wire. This observation demonstrated that electricity could produce magnetic fields, a phenomenon known as electromagnetism. Ørsted's discovery unified two seemingly disparate forces of nature into a single fundamental force: electromagnetism. Section 7. Faraday's induction, a magnetic revolution. Building upon Ørsted's discovery, English scientist Michael Faraday made a series of groundbreaking discoveries in the 1830s. Faraday discovered electromagnetic induction, the phenomenon where a changing magnetic field induces an electromotive force, or EMF, in a conductor. This principle is the foundation for electric generators, which convert mechanical energy into electrical energy. Faraday's experiments were instrumental in understanding the relationship between electricity, magnetism, and motion. Section 8. Maxwell's equations. Illuminating the electromagnetic spectrum. In the mid-19th century, Scottish physicist James Clerk Maxwell revolutionized our understanding of electromagnetism. Maxwell synthesized the work of Faraday, Ørsted, and others into a set of elegant mathematical equations known as Maxwell's equations. These equations describe how electric and magnetic fields interact and propagate through space as electromagnetic waves. Maxwell's work unified electricity, magnetism, and light into a single framework, laying the foundation for our understanding of the electromagnetic spectrum. Section 9. Edison's illumination lighting up the world. Thomas Edison, one of the most prolific inventors of all time, played a pivotal role in bringing electricity to the masses. In 1879, Edison developed a practical and commercially viable incandescent light bulb. His invention revolutionized lighting, replacing gas lamps and candles with a safer, brighter, and more convenient source of illumination. Edison's contributions extended far beyond the light bulb, including the first commercial electrical power distribution system. Section 10. Tesla's alternating current powering the future. While Edison championed direct current, or DC, Nikola Tesla believed alternating current, or AC, was superior. AC systems reversing current flow offered significant advantages, especially for long-distance transmission. Tesla's AC motors and generators revolutionized the industry. His designs formed the basis for the modern grid, efficiently distributing electricity. Section 11. Marconi's wireless waves, connecting the globe. In the late 19th century, Italian inventor Guglielmo Marconi pioneered wireless communication. Building on the work of James Clerk Maxwell and Heinrich Hertz, Marconi developed a practical system for transmitting and receiving radio waves. In 1895, he sent the first wireless telegraph signals over a distance of 2 kilometers. Marconi's invention revolutionized communication, enabling information transmission across vast distances without wires. Section 12. De Forest's triode, amplifying the signal. In 1906, Lee de Forest invented the triode vacuum tube to amplify weak electrical signals. The triode, with 3 electrodes inside a glass tube, revolutionized electronics. It became essential in radios, amplifiers, and other devices. De Forest's triode enabled sensitive radios and long-distance telephones. Section 13. Wartime innovations, radar and the rise of electronics. World War II spurred rapid advancements in electronics. The need for sophisticated systems led to radar, sonar, and computers. Radar, using radio waves, was crucial in air and naval warfare. These innovations impacted the post-war world, leading to commercial radar systems. The transistor, a semiconductor revolution. In 1947, John Bardeen, Walter Brattain, and William Shockley invented the transistor. This device, made from germanium and silicon, could amplify and switch electronic signals. Transistors were smaller, more reliable, and energy efficient than vacuum tubes. The transistor revolutionized electronics, miniaturizing radios, televisions, and other devices. Section 15. Integrated circuits, miniaturization and the digital age. In the late 50s, Jack Kilby and Robert Noyce independently developed the integrated circuit, or microchip. ICs integrated thousands of transistors and other components onto a single silicon chip. This invention marked a turning point in electronics history. ICs enabled the miniaturization of devices, leading to smaller, faster, and more powerful electronics. Section 16. From computers to lasers, the enduring legacy of electrical engineering. From the first rudimentary computers to the sophisticated smartphones in our pockets, electrical engineering has driven the digital revolution. The development of microprocessors, memory chips, and other integrated circuits has enabled powerful computing devices, lasers, medical imaging, and renewable energy systems. As we look to the future, electrical engineers push boundaries, developing technologies to address global challenges and create a sustainable world. Thank you for watching video. Like, share and subscribe to Franciumz Legacy for more videos.